So, welcome to this video. We are going to take a look at solving equations. We are going to look at solving a very specific type of equation. We're going to solve equations with variables on both sides, okay? And if you see here, I'm going to do a couple examples in this video where it says, please solve for the unknown. And if you notice here, if I just drew a quick line down through the equal sign in both of them, they would, in fact, have a variable on both sides of the equal sign. Okay? Now this is a little more complex than what you've probably seen recently, and I'm going to review what you've seen recently and hopefully add to it. So to do these problems in a few moments, I'm going to talk about some steps that I'll put in here, and you could, jot them into your notes for reference. But before I do that, I need us to revisit something that is highly involved in the problem we're doing today, and that's solving a two-step equation, okay? And I want to be able to take what you do in a two-step equation and simply just build on it, okay? So let's put a little focus on this for a moment, where it says, please solve for the unknown, okay? So if I say have an equation here that says 5x minus 8 equals 12, and I go to 5x equals 20, that should not be a shock, because if you're solving this equation and you're doing it well, you should realize that what you need to do is add 8 to both sides. Okay, and you should have that decently well mastered. And then to go from 5x equals 20 to the answer of x equals 4, you should have decently mastered that you should be dividing both sides by 5. Okay? Well, those steps are very specific to this problem in terms of adding 8 to both sides and dividing 5 by 5 on both sides. But you needed to be able to generalize those ideas into two steps. The first of which I referred to as the zero step, which is undo all additions and subtractions. And I refer to that in shorthand by the number 0, because when you undo an addition and subtraction, you are in fact making the number 0. And you've seen that what you've done usually when you do that is cross out here in the problem where it says negative 8 plus 8. And then the second generalization you needed to make, I sort of refer to as not step 1, but a step that I use the number 1 to sort of refer to, and that's undo all multiplications and divisions. And I use the 1, again, because you're making the number 1 when you undo multiplication and division, such that here when I had 5 times x equals 20 and divided both sides by 5, it's because 5 over 5 equals 1. Now just a quick review of that. If you notice here, I'm crossing out, and you notice here I'm crossing out. But when I cross out in blue, I'm actually getting the number 0. And when I cross out in green, I'm getting the number 1. Now, like I said, we need to be able to bring those steps over into this process, okay? And those steps are going to be seen here. I refer to the step as 0. It's not step 0. Its name is kind of 0. And I refer to the step as 1. And it's not step 1, but its name is 1. Okay, if that makes sense. Okay, because we're going to build this algorithm up a little bit, and we're going to have to add to it today. And what we're going to add, if we're adding another step, you want to sit there and say, well, am I adding it at the end or adding it at the beginning? A lot of people would say, I'm probably going to add it to the end because I'm adding on to the process. Well, you're actually not. We're actually going to add a step on in the beginning, and it's a step that I refer to with the letter G. And it comes from the idea of get all of your unknowns on the one side. I'm going to put get in quotes here for a second because get's a little bit of a weird word in that it's not a math operation. Get is not add, subtract, multiply, or divide, but it kind of describes the step you're looking for. So if you notice here, we're developing these steps right now for solving equations, and it looks like the thing we want you to remember is G01. And believe it or not, I'm going to add to this eventually. So you have to get this mastered, and we're going to keep adding things to it. So for right now, we're going to look at doing G0 and 1, and I'll try and color code this as best I can. Okay? So we're going to do the G step first in this equation where it says solve for the unknown, okay? And it says 4x minus 8 equals 12x plus 4. Well, for me to get all of my unknowns on the one side, I've got to get rid of a pile of x's, okay? In sort of layman's terms here, I need to get rid of the 4x or get rid of the 12x. I'm going to choose to get rid of the 4x, okay? And if this says 4x here, I'll subtract 4x from both sides, okay? So what I'll do here is, in appropriate writing left to right fashion, I will say 4x minus 4x cancels, bring down my negative 8, bring down my equals, 12x minus 4x is 8x, and bring down my plus 4. Okay, now from there, I'm going to look to undo all of my additions and subtractions, which is given by this step I call 0. Okay, so what I'm going to do here now is see that I have a two-step equation, so I'm going to subtract 4 from both sides. Okay, and then in writing in left to right fashion, negative 8 minus 4 is negative 12. Pull down my equal sign, pull down my 8x, and then 4 minus 4 is 0. Again, that's why I refer to this as 0, because you're making a 0. Just move my steps down a little bit so I can have a little bit of space. Okay. Excuse me, just a little zoom. Okay. And now I'm going to undo all multiplications and divisions, which I talk about with a 1. So it says 8 times x, so now I will undo the multiplication by 8 by dividing by 8. Okay? So now I'll write my answer to negative 12 divided by 8, which is negative 1.5. You can go in your calculator to verify that. Pull down your equal sign. Okay? And then 8 over 8 cancels. It makes the number 1. Pull down my x. So if you notice now, I have, in fact, solved this equation. It says x equals negative 1.5. You can check that on your calculator, okay, by plugging it back in for x and typing the original equation. Okay, so now, again, I'm going to try and look at this G01 method in this next problem where it says 2a equals 4a minus 17. So when I go to solve, I'm going to look to get all my letters onto one side. If you notice, I have a's on both sides. Now there's two moves here that are totally legit to do this. I could subtract 2a from both sides. Okay? I'm going to hold that aside for a second. Or I could subtract 4a from both sides. Okay? Well, a couple things with that. If I were going to subtract 2a from both sides, let me just try and group this together. Okay? It would make the problem a little bit difficult, because if you notice here, some kids would cross this out, pull down their equal sign, do 4a minus 2a, it's 2a, and pull down their minus 17 and say, I don't exactly know what to write over here. Is it a, or is it 1, or, well, if you realize that it's 2a minus 2a is actually 0, which makes sense, because you're in fact canceling that. But that is a little bit awkward. So to tell you the truth, I like the other option we talked about first, where you don't lose the entire left side of the equation to a 0, and that's to subtract 4a from both sides. Now, if you notice here, when I work down, I'm going to get 2a minus 4a is negative 2a. Pull down your equal sign. 4a minus 4a is still going to cancel, and then pull down your negative 17. Now, if you notice, I'm going to look to undo my additions and subtractions here, and some of you might look here and say, oh, that's a subtraction, so I'll add. That's not true. This is multiplication still, of a negative. So what I'll do next is realize that I don't have any additions or subtractions to undo, so I'll skip that. And then move on to undoing all of my multiplies and divides. This is negative 2 times a, so I'll undo that with division by negative 2. So we see here that negative 2 over 2 cancels. So I'll write a, again, because negative 2 over negative 2 creates 1. Pull down your equals. And negative 17 over negative 2 gives you 8.5. That is the number that we could use for a to make the equation true by putting it in here, and it would check out. Okay, so here's the deal. When you are trying to develop an algorithm for solving equations on both sides, this is the best recipe. Is it hard and fast that you must do every problem like this? No. I'm giving you this algorithm because doing these steps in this order avoids mistakes. Okay? It does the majority of problems you will encounter. So it's a great place to start, and you'll learn little nuances about how you can do things another way by trying to do them this way. Okay? And again, in the days that come after this lesson, you're going to see me add even 2 more steps to this algorithm. I'll give you a little preview now. I'm going to refer to them as D and C. So the whole algorithm is going to become DCG01. You'll see that. Okay? But for right now, you guys are working on just G01, which is G is get all your unknowns on the one side, 0 is undo all your additions and subtractions, and 1 is undo all your multiplications and divisions. And again, this idea of undo is based on the idea of using the inverse operation. What undoes add, subtract. What undoes subtract, add. What undoes multiply, divide. What undoes divide, multiply. So I hope this was a help to you, and enjoy. Feel free to watch it again, and make sure you practice.